So yesterday we talked about writing two-step equations. And today we're going to finish that out with example 2, which is a real world situation. So it says you buy 3 books that each cost the same amount and a magazine, all for $55.99. You know that magazine costs $1.99. How much did each book cost? So first off, our unknown is how much does each book cost, because we do not know that. So we're going to say let B represent the cost of each book. So now we just need to write our equation, but we need some important facts. Well, you bought 3 books and a magazine, and that magazine cost $1.99. Our total cost of our bill was $55.99. So we have to write that. So 3 times B plus the $1.99 we spent equals $55.99. Now we need to isolate our variable, our V. So that means we need to move everything to our opposite side of our equal sign. So we're going to subtract $1.99 from both sides. That is going to give us 0 here, because $1.99 minus $1.99 is 0, gives us 3B. 55.99 minus 1.99 gives us 54. And we can do that by hand too. 9 minus 9 is 0. 9 minus 9 is 0. 5 minus 1 is 4. Bring down your 5, 54. So now we're going to divide both sides by your coefficient, which is 3. And then 54 divided by 3. It's going to give us 18. So the cost of each book is $18. You can put a dollar sign, or you can put the word dollars. B. A personal trainer buys a weight bench for $500. W weights for each weight is $24.99. The total cost of the purchase is $849.86. How many weights are purchased? So what we're looking for is how many weights were purchased. How many weights were purchased? So we're going to say and we're going to use that W they used up here. Let W represent each weight purchase. Now we need to know what all the personal trainer bought. He buys a weight bench for $500. We know that each of the weights are $24.99, and he spent a total of $849.86. So that is going to be your equal. So first he bought a weight bench, which is $500, plus $24.99 W, because that's where your weights are, and then $849.86. So again, this is our variable. We have to isolate that variable. So we need to move our 500, which has no variable. So minus 500 from both sides. That cancels out, because 500 minus 500 is 0. So we have $24.99 W. And then we have to subtract. So 849.86 minus 500 equals 349.86. 24.99 is the coefficient, so we need to divide both sides by 24.99. So So I already have that in there. I'm just going to say divide 24.99. And I get the answer of 14. So the trainer purchased the personal trainer purchased 14 weights. So our very last question, which is C for our notes for today, it is about temperature. It says the current temperature is 54 Fahrenheit. It is expected to rise to 5.5 Fahrenheit each hour.
If you have an Eric Redding, can you send it to the front office, please?
So you have to excuse the noise from the intercom because I'm still at the school. The current temperature is 54 degrees Fahrenheit. It is expected to rise to 2.5 Fahrenheit each hour. In how many hours will the temperature be 84 Fahrenheit? So we're trying to get to 84, and we need to know how many hours will that take. So we're going to let H represent each hour. Done. And that is it. I just messed it up. All right. So now we have our current temperature, which is 54. We know that it rises. That's going to mean add. Here. Each hour, 2.5. So 54 plus the 2.5H equals that 84 we need to get to. So the first thing you need to do is isolate your variable. How do we do that? Well, there's the variable. We got to move that 54. How do we move it? We have to subtract it from both sides. 54 minus 54 is 0, and that leaves 2.5H. This 4 minus 4 is 0. 5 minus 8 is 3. So 30. Now we're going to divide both sides by the coefficient, which is 2.5. So 30 divided by 2.5. My calculator. I got the number 12. All right. So it will take 12 hours for it to rise to 84 Fahrenheit. So this was all the notes that we did today, A, B, and C. Tomorrow we're doing, our work for tomorrow, kind of working it out and doing it ourselves. So hopefully this helps you if you did miss the lesson and that you listen. And I hope you have a good day.